So we're going to be talking about system probability. So you have two events, A and B, and the union of these two events consists of all events that occur in either A or B or both events, as can be seen in the Venn diagram. So we denote this as A union B, as seen. So now for the intersection of these two events, this is all outcomes that occur in both A and B, which is that tiny little sliver, and it's denoted as A intersection B. So we say the probability of A union B equals P of A plus P of B minus P of A intersection B, and this is the standard definition. So for the intersection, we know that the probability of A intersection B equals the probability of A times the probability of B. So by substituting this equation into the union equation, we find that the new equation is the probability of A plus the probability of B minus the probability of A times probability of B. So let's say we look at some system arranged in the following way. So we have 6 components and they all have different probabilities of working. The first two are 0.9, 3 and 4 are 0.8, and 5 and 6 have a probability of 0.7. So the probability of the system working equals the probability of A1 intersection A2 intersection A3 union A4 intersection of A5 union A6, so that this is including everything in that tiny intersection to find the probability of the system working. So by definition, we can make this the probability of A1 times the probability of A2, because that's the definition of intersection, times the probability of A3 union A4 times the probability of A5 union A6. Once again, do the definition. So from here we can expand from the definition of union, making it P of A1 times P of A2 times the quantity from the definition once again, P of A3 plus P of A4 minus P of A3 intersection A4 times the quantity P of A5 plus P of A6 minus P of A5 intersection A6. Okay, so from here we can once again reduce via the intersection, the definition of intersection. So we know that it's P of A1 times P of A2 times the quantity P of A3 plus P of A4 minus P of A3 times P of A4 times the quantity P of A5 plus P of A6 minus P of A5 times P of A6. So now going back up and looking at the probabilities for each component, we can see that we can plug in all of these numbers and we end up getting 0.9 times 0.9 times the quantity 0.8 plus 0.8 minus 0.8 squared times the quantity 0.7 plus 0.7 minus 0.7 squared. And this ends up coming out to be 0.573. So this means that there's a 57.3% chance that with the arrangement of these components that the system will work. What did I say? Okay. Thank you for watching, and I hope you learned a lot.